All right, we'll be live in a second.
Is there a link for the internet
A link for the internet, sure.
that I can tweet?
If you want. By the way, we're live.
Oh, hello.
uh, okay. Yes. Where did I put it? Here it is. All right. I'm gonna email you back
Okay.
that the link. So if you want to do this Twitter thing, I totally broke down this week and reinstalled Twitter on my phone, which is
Don't
just
look at the feed. Don't look at your home feed.
it's just a terrible idea. I mean, until I can actually inject anxiety directly into my brain, this is the best I can do. Right? So,
You get up in the middle of the night and do it. It's really depressing.
oh yeah,
Oh,
no,
God.
I've been waking up at like 4 in the morning. I'm like, well, I can't sleep. So I wonder if the world is still burning. And then you think,
Damage
yep,
report.
yep.
Damage report.
Promise it will be. Just don't.
I know. Actually, Carl and I have instituted a fairly clever idea, I think, which is that we're only allowed to talk to each other once a day about the epidemic, about the pandemic. So when we get up
Not
in the
bad.
morning and we're
Not a
having
bad
our
idea.
coffee, we can go, oh, did you hear that? Prince Charles has the virus, and oh, did you hear that? And then at the end of an hour, then that's it for the
Yeah.
rest of the day.
Yeah.
Yeah.
And if you've discovered some awful new piece of information, you just keep that to yourself till tomorrow.
Yep.
And that's worked, actually.
Yeah, that's a good rule.
Yeah.
That's a good rule.
You need to do the mental sanity thing too,
Yeah.
It's important.
Yeah. I'm going to say hi to some people. Hello to Andy Cowley, Ben Kalo, Bob Moeller, Brexit Denier, Carl Pemberton, I can't even talk anymore. David Dunn, David Fairweather, Ian Farquharan, James Haney, John Musk, John Seffield, John Wells, Johnny J, Jorn Albert, Kim Barron, Larry Beckham, Luke Duke, Nancy Graziano, Paranor, Arjone, Scott Bragdon, Subject Line, Visto Tootie, Wayne Francis, and I believe that's it. Did I say Larry Beckham? You just said hi. Anyway, apologies if I didn't say hello to people beforehand. Yeah. All right. Well, I think we've reached our 5-minute mark, so let's just begin the show.
All right.
Back to the speaker view. Oh, and you know how this works, Amy? We're going to talk to you for 15 minutes, and then you're free to go.
Okay. Sounds good.
Yep. Close the window. You have less responsibilities as a guest as opposed to being a panelist.
Yeah.
It's a sweet gig. All right. Here we go. Welcome to the Weekly Space Hangout for Wednesday, March 25th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the three-body problem, proving that time really only points in one direction. The science of suborbital flight, and evidence that Comet 2I Borisov is blasting out chunks, and 4 new mission concepts that NASA is going to be investigating. Joining me this week, we've got Alex Tichy. Alex, welcome back. Your second Weekly
Thank you.
Space Hangout.
Yeah, it's great to be here with you again.
And so just I'm gonna have to find out, where is everybody? So where are you, Alex?
I'm right here in New York City.
So you're in the full lockdown.
Right? Yeah, full in the thick of it. Fortunately, doing just fine right now. But thoughts with everyone here in
Yeah.
New York and across the country and across the world.
We've got Carolyn Collins Peterson. Carolyn, the space
Hi
writer.
there. Hi.
And where are you, Carolyn?
Well, I'm actually high in the Rockies, but I'm standing in front of Griffith Observatory in my virtual set.
That's perfect. I love it. All right. And we've got Alan Versfeld. Alan.
Hi, yes, I'm in Pretoria in South Africa.
And you guys are going on lockdown like tonight, right?
Yeah, we've been under voluntary, closed business for about a week, but they're getting serious about it at midnight local time. Tonight.
Yeah, we're still on the voluntary, right now with essentially all non-essential businesses closed, and the Prime Minister of Canada yesterday, a couple of days ago, he was just like just go home. Don't make us force you, but we will if we have to. So we'll hopefully we won't get to that, but
And he's such a nice guy.
So joining me, all right. So before we get into this week's special guest, who you probably see her name. You even saw she was there, but we're just gonna continue the illusion of rolling this out in time. The anticipation will be worth it. So before we get into this, I just want to remind everybody that we couldn't do this show without the incredible hard work from all the volunteers with the Weekly Space Hangout crew. They are the volunteers, the friends, the executive producers. They are in charge, and I am just their puppet. So if you want that kind of power over my day-to-day existence, go to wshcrew.space, and then you can just decide who I talk to, when, where, and how. It's awesome. And before we get into the rest of the show, I just want to say, just to everybody around the world, wherever you are, we are all in this together, right? This is a worldwide event that every single one of us is enduring, and I know it feels scary and hard, but we can get through it, and we will get through it together. And a year from now, I hope, 18 months, when we've all got the vaccine, that we will see this receding in the rearview mirror, and we will all be getting on with our lives. And I just hope that everybody's able to stay home and stay safe and minimize the impact on their lives. So we're all thinking about you. All right, let's move on to our special guest, Amy Shira Teitel. Amy.
Hello. It's good to be back after many years.
Yeah. This time as I think this is like your second time as a guest, because you were either working on some project or working on a book, and it's the latter. Have you got the real one?
I do. I have the hardcover here.
That's
It's all
awesome.
nice and orange and fun.
I've got the advanced copy. Yeah, which
the
I'm
one
sure...
that has a good number of typos in it.
Oh, does it?
That's the one that when I narrated the audiobook, it was that copy, and there were, I think, 85 things that had to be adjusted.
And were you editing yourself as you read it out loud?
Yes, because I had to. If there was something that I realized I said, it was like, hang on, that sentence, there's something that's not right. That sentence does not make sense. I'd have to figure out how I want to change it, speak it for the audiobook, and then make sure the physical book mirrored that so that it was the same, right? Yep. It was actually like the perfect timing to do the audiobook while we were getting the final pass on the manuscript, because I got to check all of those little things that, like, you can reread your book and you will never find all of those things, but you read it out loud with someone listening, you will find them.
Yeah, that is a pro tip.
Yeah.
Like anyone who is writing a book and has to record the audiobook,
try to schedule it if you can.
That's incredible.
Perfectly, yeah.
Yeah, I get that too, where I'm doing a video and I've got a script for the video, and I'm reading out the script, and I've already tested it and practiced it, and I'm doing the script, and then suddenly I'm like, okay, that's wrong. And then I will have to sit down and, like, in my mind, come up with a new version. And people have even caught me because the things that I'm saying don't match the closed caption, because I forget to go back and update the closed caption, which was based on the script. So, so tell us about the book.
Yeah, so the book, I feel like even though you can see it, it's called Fighting for Space. It is available everywhere books are sold, also for order online so that you don't have to leave your house, and also audiobook and ebook editions, everywhere in the US and Canada right now. And it is the story of two female pilots, and there's some more in there, it's not just two, but primarily two female pilots, and kind of them navigating being pilots at the time when America was starting to take its first steps into space, and what that meant for women who were already at a disadvantage in a male-dominant field of aviation.
See, that's super weird to me, because I know that there were plenty of female astronauts back in the original Apollo program, so and earlier. So what's going on here?
So this is, okay, so the way I kind of bring it up is you may have heard of the Mercury 13, which is kind of how these women are typically known. And I do discuss in the prologue that is wrong. That is a very bad misnomer for this group of women, because there were arguably not 13, because one actually withdrew her name from contention because she was going through a divorce. They were not a group. They never actually met as a group, although they all knew each other. Yeah, there's this idea. So, you know,
that they were a team.
They're a team. They're united, but they're really not.
Yeah.
So, you know, we've seen the right stuff, and that, you know, all the astronauts getting the needle in the hand, and they're going like this, and then running down the hall with the enema bags. Like, this is what the women did in the medical testing, because that was the medical testing. The men were doing it as this big group, and they could buck each other up, or as men do, kind of like goad each other to kind of will each other on.
I'll bet you cried during the enema. Yeah.
Exactly. It's the way men do. This is what I've learned from Seinfeld, which I'm watching right now. Where the women were going in pairs sometimes, or they were going individually, because they weren't a group. They weren't government funded like NASA was. They weren't a program. They were an independent study done by Dr. Randy Lovelace, and they kind of did it when they had time. So, you know, some women had to quit jobs. Some women had to get sitters for their families. They had to kind of coordinate schedules when there was an opening. So they didn't all meet as a group. They weren't a united front. And they also didn't agree on what their program, quote unquote, should be, which was the most interesting thing for me in researching this. Is some of them thought Jerry Cobb, who's kind of the typically portrayed as the leader of the group in this story because she did the testing first. Some of them thought Jerry was going about it horribly and was actually ruining their chances of getting into space instead of helping their cause. And they you know, went on record saying, she does not speak for me. So why is it that we have this story where like Jerry is the intrepid leader of this group of women who are united behind her? Because that didn't happen at all. So that's kind of where this book fits in with that typical story. And so I feel like I should do this because it's video and I can motion to things. So this is Jerry down here. So she is definitely one of the key players in here. But the other woman up here is Jackie Cochran. Now, Jackie is an interesting person in this story because she's typically the villain, but she's kind of the villain in the way Maleficent is the villain in Sleeping Beauty. That's the analogy I like to make, because she's evil and totally without reason. So typically in stories, Jackie like swoops down out of nowhere, testifies before a Senate subcommittee or a congressional subcommittee hearing that women should not fly in space, and then just like pieces out and never really does anything else. And she's just evil and there's no reason why. So when I started looking into the story, because there's other things about the story that just didn't work for me beforehand. Like, why are we talking about women in space and ignoring the fact that this is also when NASA's figuring out the mission mode? Like, of course NASA has bigger things on its plate. I started looking into Jackie, and it turns out she's like the biggest badass that I've never heard of. And I was like, why is she not a household name? And the story is actually Jackie's story because Jackie knew everyone involved. LBJ was vice president at the time, Lyndon Johnson, and Jackie was a good personal friend of his and had saved his life one day. Jackie was good friends with Randy Lovelace. Her husband was bankrolling the clinic.
You know, I have watched the documentary on Netflix.
The Netflix one?
Yeah. I think that was the Mercury.
Yeah. It's called Mercury 13.
Mercury 13, yeah. And I think you and I had actually talked about it when we were in Australia. And you were griping about it, but the fact that Jackie was a badass had definitely come through that documentary. That she was sort of pound for pound one of the finest pilots in the United States,
in the world,
bar none, gender regardless. And had every right to fly as high and as far as she chose to go.
Yeah.
But the impression that I really got from the documentary was that she tried to sort of go after achievable goals as opposed to change the paradigm, right?
Yeah, I think Jackie and the first half of the book really explores kind of early aviation. With a lot of it is Jackie because she is 25 years older than Jerry, and her storyline starts before all of the space stuff. But it helps you understand why she did the things that she did a little bit. And I will go into this saying, like, everyone involved in this story had an agenda and ego. Like, women are not exempt from this, like, enhancing stories to make themselves sound better. And like, Jackie's memoirs are full of her little embellishments, as are Jerry's, to be clear. But you see that Jackie kind of, she wanted, when she learned to fly, when she's starting to fly in the 30s, she really wanted to be the best. And that meant the best among men and in male races. So she broke those barriers for herself and other women so she could be the best. And she started the Women's Air Force Service Pilots in the Second World War to prove that women could fly and keep pace with the men. But she also knew how hard it was. She knew how hard it was to convince men that women could do it, to convince them to even give women a shot. So when Jerry comes and starts doing the same thing and trying to create a women's space program or just inject herself into the astronaut corps, Jackie was in a position, she had age and experience behind her to know that you can't just say, well, I'm good enough, which, by the way, she was not qualified according to NASA's own requirements at the time. She knew that you couldn't just say, well, women are lighter, therefore send me into space, that it was a political game that you had to play. And Jackie had been playing it for years. And she'd earned the respect of the people that made the decision. And she was, knew how to leverage that and knew what she could get realistically, instead of just like, okay, let's totally change the game and throw out everything I've learned in my 50 years experience of being a woman here.
So how close were they to actually having a female astronaut earlier than Sally Ride?
Yeah. So, and this isn't in the book because it didn't fit. I'm working on some sort of supplementary stuff about it right now. But Jerry and co were not close to flying in space at all. They did not meet the base requirements. Jerry herself was like dubious how well she actually did on some of her testing. So, personality wise, she probably might not have been selected. But NASA actually started looking at women astronauts a couple of years after the congressional hearing in about 1964, when it started looking at the group of scientist astronauts, right? This is the group looking ahead at Apollo. We're going to need people to do really big science returns. So let's send a geologist, let's send, whatever science people we need and teach them how to be astronauts, not take astronauts, teach them how to identify rocks, because we all know how difficult that can be. Apollo 12 had like cheat sheets, right?
Yeah.
So in 64, I believe it was, NASA actually had 4 women scientists on its short list for the next group of astronauts. And it sent that list. I don't know exactly what happened, because there's not a lot that I've been able to find, nor was this what I was like desperately, searching for details for. But NASA sent that list to the National Academy of Science. And when the National Academy of Science sent the list back to NASA with its recommendation of the top people, the women were not on that list. A bunch of men had also been cut. So it's unclear whether it was, Jerry kind of created a bit of a sore spot. We don't really want to deal with the women thing right now, so let's shelve it. We have a lot of things going on with Apollo. Maybe let's not introduce the idea of like, is it safe to send a woman with 2 men? Is it like plumbing wise is different? Like, can we figure out how to do this? Let's take one thing out of the equation. Or if it was straight up qualifications, I think it was only like 6 people. It was a very small group, maybe 6 or 8 in that group. These are the top guys of like 50 people on our long list. So we're just going with the best for what we need now. So it's unclear why, but NASA did start looking in the mid 60s that women are qualified and women have things to do. They just didn't qualify under the astronaut at the time.
Yeah.
Of course, then in the 70s, everything was changed to mission specialists, which included scientist astronauts. Hence Sally Ride.
What impact did the advances of the Soviets have on the American program? Was there this window where you had Yuri Gagarin, and then it was, a few years until the Soviets were able to send a woman into space? Did the Americans see this as an opportunity at all to beat the Soviets on just some front, or did they just let that milestone go too?
They definitely let it go. The way the timing works out is actually pretty interesting. So after the Senate, I keep wanting to say Senate, I don't know why, the Congressional Subcommittee hearing in 1962, Jerry testified, Janie Hart, another woman testified, Jackie testified, John Glenn, Scott Carpenter, and George Lowe testified on behalf of NASA. After that, the story kind of fizzled, and whatever semblance of order the group of women had kind of dissipated. Jerry was still trying to get her own space flight. Her motivations become very clearly self-interested as her letters and pleas go on. And her last-ditch effort was really publishing her first memoir in 1963 called Jerry, I think it's Woman into Space, the Jerry Cobb Story. It's all about like her epic story and like how it's a God-given purpose, this whole thing. It was published in June of 1963, and her goal was to actually drum up enough interest and public support to sort of force NASA into flying her. Well, unbeknownst to anyone else, the Soviet Union was looking at all this coverage of Jerry and thinking, well, if they're going to do this, we should do it first. So same month. So
Irony.
Jerry's whole thing is, I want to be the first woman. Let's score a propaganda victory. And NASA's like, but we're going to the moon, and that's kind of more important. The Soviets sweep in with that propaganda victory exactly the same month that Jerry's memoirs are published. And of course, Valentina Tereshkova is just, the perfect figurehead of the Soviet Union at the time. She's a parachutist. And I always feel really bad when, young girls want to interview me about Tereshkova and how she kind of changed things for women in space. And I'm like, but it was 19 years before another woman flew. Like, she was definitely a political move. She was 100% a political move. And after her flight, NASA didn't make any moves to fast track women. America was like briefly interested in the idea of women in space, but it didn't go anywhere.
Yeah.
What NASA did actually was start to highlight the women who were a part of the space program, but they were the engineers, they were the calculators. This is where Nancy Grace Roman really started showing up in every single article. It's like her and Dio O'Hara, who was the astronaut's nurse, are like everywhere all of a sudden. And Jerry's still there too. But the idea was women are involved. They're just not the tip of the iceberg. And that's kind of the line NASA held until Apollo was done.
I would love to think that the issues and the challenges that women faced back then to be able to fly in space are over, but it's possible that still there are issues, institutionalized sexism and all kinds of things. So what are some lessons that maybe you learned in writing this book, in talking to these women and thinking about our current state of just like having women do all the same jobs as men? Have we crossed that line yet? Or is it still pretty, are things still skewing maleward?
I think there's definitely a lot of systemic sexism that still exists, which is why writing this book was really fun for me, was because a lot of things I'm like, oh, this is still a thing. This is still the exact same argument that people make. But I think what was really interesting in doing this is that it's so easy to look at what happened in the early 1960s from a modern standpoint and think, well, why didn't they just listen to them? Of course they were right. But in 1962, things were very different. The political landscape was different. These technically where spaceflight was very different. Even just things like the word feminism meant something different in 1962. It was akin to communism. And it was not like, I have 3 women saying I am not a feminist in this book, because it was not something that you wanted to admit to. Whereas now, if the same thing happened, there would be a Twitter storm.
Yeah.
And NASA would have to cave to public pressure probably.
Yeah, they'd be canceled.
They're very different.
Yeah.
So there's like, I'm not sure that where the lessons learned are necessarily, because it's such a unique case study, but it really does. I think there's a really interesting theme in there of like, know what you're up against, because I think in a lot of disciplines, a lot of fields, women are still up against something, and that something will vary, whatever it is. And it's not always enough to just say, I know that I'm good enough, therefore let me do this, because sometimes you have to go around. You have to do that extra step, that extra mile to prove that you belong there, to prove that you're worth it, which sucks.
Yeah, I think that's the impression that I get, as a straight white male, is I get, I see my female comrades having to work twice as hard to get to the same positions. Larry Beckham is noting in the chat, right? It's time for for a woman to be an administrator of NASA. There's a thing that hasn't happened yet.
That's true. That's true.
Right.
And then, but then I always feel like on the flip side, people will say, I've done so many interviews and talks about this book. People are saying, aren't you excited for when NASA launches an all-woman crew? And I'm like, only if it's because they're the right people, because then you have the tokenism of the all-woman crew to say that you did it.
Right.
And then it's not about
done.
space.
We don't need to do that again.
And then it's sort of like, well, why I really want to get past all of it to where it's like the right humans for the job because we're all humans, and that's where it stops, which I realize probably won't happen until we're all like, I don't know, wearing those jumpsuits of futuristic movies from the 60s. Like, it's on the, as much as I want to say like, yeah, there should be a woman, this woman, that. It's like, unless she's there as tokenism, because then it doesn't help anything. You feel better.
Yeah.
But she's going to be wondering, why did I get this job? And that also sucks.
Yeah. Yeah. Well, Amy, it was a pleasure to have you come and hang out with us and talk about your book. Congratulations.
Yeah, thank you for having me.
2 books.
Available for all your quarantine killing.
That's right. Yeah. People got a lot of time on their hands now. They can listen to the audiobook.
Listen to it. And I'll just say again, I read it this time. So it's in my Canadian accent.
Eh?
Eh?
Awesome. Amy, thanks a lot. And
right.
Are you going to do another one? Had enough writing yet?
I mean, eventually, not yet.
Yeah.
I want to relax.
Yeah, there's a lot of therapy sessions that have to come after a book launch. Then
there's going to be a little bit of downtime
eventually,
but I don't know what that'll be yet.
Yeah.
But
well, congratulations. Two is like 1,000 books.
It's a lot.
Yeah.
It's a lot of stuff.
All right. Take care.
All right, thank you.
Have a fun
Bye.
quarantine. We'll see you later.
Yes, you as well. Stay safe, everyone.
All right.
You too.
All right, let's get into this week's space news. Alex, you're on my screen right now, so I would like to talk about Comet 2I Borisov.
Yeah. So this was just something that I spotted online. It's it's kind of a slow week for obvious reasons, but there's still people are slowly, there's still stuff happening, and definitely stuff happening in the universe and in our solar system. So Comet Borisov is a really special object. It's an interstellar comet. It's only the second interstellar object that we have discovered. Listeners and viewers are probably familiar with Oumuamua that was discovered back in October 2017. You can tell that it's from outside of the solar system because it's going too fast, and so if you take its velocity and its trajectory, you can calculate its orbital energy, and you realize that its eccentricity is greater than 1, which means it's on a hyperbolic object. It's coming in from someplace else, and it's going to zoom outward again. Oumuamua, we caught it when it was on its way out, but in the case of Comet Borisov, we saw it actually when it was on its way in. So that's been pretty cool because we've been able to observe it for over a year now, about 390 days of observations on this object, and it is flying. I mean, it's got an eccentricity of 3, which means it's really hauling, and so now it's on its way out of the solar system. It's about 3 astronomical units away from the sun, and it was just in a telegram. When we perform these observations and you really want to get the word out very quickly, you don't have time to publish a paper about this or anything. You just want to get the word out to all the astronomers. It appears it has brightened quite a bit by 0.7 magnitude, so it's getting brighter as it goes out, and the authors of this telegram are interpreting this as it's breaking up. So that's not terribly weird. It's a comet. It's made of ice. As it comes in, it's closer to the sun, it heats up and it's outgassing, and so that material is spewing out into space, and therefore the nucleus gets eroded over time, and then evidently, like I say, the astronomers performing these most recent observations are interpreting this as a breakup event. So one trip in through the solar system, it's probably been drifting out in space for hundreds of millions, billions of years, and now it got its few days in the sun, and that's about the end of its journey for this comet. So yeah, I thought it was pretty cool.
So I mean, Oumuamua, as the first interstellar object, was such a bizarre object. Right? It had this really strange brightness profile. It was clearly rotating quickly. It was getting 10 times brighter along one orientation than its other. Astronomers argued, is it a comet? Is it an asteroid? I don't know if the final decision has been made. Is it an interstellar probe? Probably not. But still, is it a comet? Is it an asteroid? It's been a puzzle. Borisov has not been a puzzle. It has completely lived up to every aspect of it's a comet, which is kind of incredible because it came from another solar system. So the fact that you've got this object that came from another solar system is behaving like just a regular old solar system comet. And so this behavior, right, this breaking up, getting brighter at this point in the trajectory, this is exactly what you'd expect from a comet?
Yeah, I would say so. I mean, I'm not comets are not really, what I work on, but, I was a little surprised when I saw this, that it's breaking up, a full astronomical unit beyond its perihelion. It's perihelion, of course, is when it makes its closest approach to its sun. And this was around 2 astronomical units. So you might remember this comet Ison from a few years ago that everybody got super excited
Ison
about.
let me down so hard.
Yeah, I remember, looking for it before perihelion, and then after perihelion was when it was really supposed to be spectacular, but then it just totally disintegrated when it made its closest approach to the sun. So I was actually a little surprised that it's breaking up now, not rather than during its closest approach. But if you think about what's happening here, this material is getting eroded, and there's all different kinds of ices, ammonia ice, carbon dioxide, carbon monoxide, and these things all sublimate at different temperatures, right? So what happens on the way in is going to be different than what happens going out, and at a certain point, I suppose it just reaches a breaking point, and it just kind of disintegrates a little bit. Oumuamua definitely was the weirder one, and I think in large part the reason that people thought it was, or one reason that people thought it might be a space probe or something like that, was because it was seeing this what they called non-Newtonian acceleration, that it was actually speeding up. It was going faster than it ought to, based on its outward trajectory. Turns out it looks like this was just some sort of outgassing, but even that was a puzzle because we didn't really see the signatures of outgassing. Outgassing is a natural explanation to see some sort of non-gravitational acceleration, but you expect to actually see something.
Yeah.
I have a colleague up at Yale who's been writing a paper on this, and I just checked; it's not out yet, but they have some sort of intriguing ideas about what could be happening there.
Oh,
so,
really?
So we'll have to stay tuned on
That's
that.
Interesting.
I can't spoil it for them.
No, don't. Definitely don't. It's sort of interesting, like when you think about the Pioneer anomaly that happened with the Pioneer spacecraft, right? And it was a big puzzle. Why were the Pioneers accelerating in a funny way, and they couldn't figure it out? And they finally figured out that it was heat coming off of a certain portion of the nuclear batteries on board the spacecraft that were being sort of transmitted, and all it took was a few photons of heat to be able to change the trajectory in a very measurable way to the spacecraft. And so I can just imagine all kinds of scenarios where there's some kind of shape, some kind of shininess, who knows what it is that could be affecting the behavior of the comet. And it's so exciting to think that we have these objects passing through the solar system that started out in other star systems. I mean, for you as an exoplanet researcher, this is a gift, right? Go get one.
Totally.
Right?
Yeah, exactly right. So I think this is really sort of the coolest thing about it. Obviously, it's cool to just think about that these things are coming in, but this is really the other stars sending us, some stuff to kind of look at close up. I mean, we really can be thinking seriously, and people are, about sending spacecraft to these objects. Now, it would be very challenging to scramble a mission. You see something coming in the case of Oumuamua, we saw when it was already on its way out. But there are serious talks about, maybe parking something in orbit that, next time you spot some of these things, you just, you kick it into high gear and fly out and meet it and actually do some in situ observations, experiments even on these objects, that would be really phenomenal.
Yeah, there's going to be a mission that's going to go along with ESA's aerial program. It's the Comet interceptor, and the plan is probably 2028 to bolt a little interceptor together with this spacecraft, and it's just going to chill out in the L2 Lagrange point waiting for a target, and then as soon as one does show up in the solar system, fire its rocket and try to make an interception and take some pictures up close. We posted a picture of just today of the surface of asteroid Bennu, the latest super high resolution mosaic that NASA had released that just shows in incredible detail every single part of this asteroid. And someone in Twitter was saying like, wow, I can't believe that NASA can make images with this high quality. I'm like, well, you send a spacecraft up close, hundreds of millions of kilometers away, and the rest sort of takes care of itself, right? Which is you can get close. It's incredible what you can do. And that's the key, is to get close. So awesome. I can't wait for the next. We've seen 2 in a couple of years. That just means there's going to be more, and we're going to find them, and we're going to study them, and it's going to be a boon for science. So
yeah, I think the estimate is that at any given time, there's at least one of these objects in the solar system. So it's a matter of finding them in time. Really.
I've seen simulations that there could be tens of thousands somewhere.
Well,
but not necessarily up close where we can observe them. I mean, the solar system is a big place, right? 2 light years away. Right. So it's a big place.
Right.
Yeah. Well, thanks, Alex. Carolyn.
Yes.
What do you got for us?
Well, about 3 weeks ago, I was invited to attend something called the Next Generation Suborbital Research Conference. And I have to admit, I didn't know a lot about suborbital research. I thought it's balloons, it's suborbital rockets. And when I wrote one of my books about this, we've had suborbital rockets going up since late 40s. We've had balloons going up to do science, but it's gone way beyond that now. And so this meeting was sponsored by Southwest Research Institute, and Alan Stern was the organizer for it, along with his team. And he's been doing quite a bit of work with that. And it gathered together about 300 researchers, scientists, educators, representatives of vendor companies for rockets and things like that. So we had people from Northrop Grumman and Blue Origin and Virgin Galactic and others. And we had 3 days of papers and panels and discussions about suborbital science. The NASA administrator gave a talk. He showed up for like an hour and a half and then flew out. And then the next day we all found out he was sick. So that was kind of interesting. And this was pre-quarantine. So we're all being very careful to bump elbows with each other and do that kind of thing.
Like he wasn't coronavirus sick, was he?
No.
Okay.
I think it was probably just too much travel.
Right.
But anyway, he talked about the link between what NASA's doing and how the suborbital research kind of feeds into what NASA's doing and how it also feeds back. So it was kind of an interesting talk, and I was really impressed. I mean, I didn't really know much about him, but he gave a bang up talk, and he does his homework. He really knew what he was talking about. So the suborbital research today, now what I learned at this is it is still balloons. So you have Worldview going up and sending up these stratolytes and doing basically Earth-facing research for the most part. You have rocket flights. So some of the most famous ones are Blue Origin sends up flights. There was a couple of experiments that were talked about. One of them was a group of second grade students who sent up an experiment to see if fireflies light up in space, and they do.
Oh, cool.
It was interesting. I mean, this is Purdue University got them involved with this.
Yeah.
Northrop Grumman was there, is another one that does rocket flights. We have aircraft like the Comet type aircraft. Zero G Corporation does that, as a pretty big name for that. And they send up and you get 15 parabolic microgravity experiences. And then Virgin Galactic Spaceship 2 sends you up to above into space, and you're up there and you basically hang and then you just come back down.
Yeah.
And Beth Moses, is their astronaut trainer, and she's an astronaut, used to be at NASA, gave a really compelling talk about what that was like, to be up there and just hanging at apogee and then going back down again. And I was just totally blown away by that. And then there's other smaller cube type experimental boxes that are launched by Blue Origin and kind of an interesting little company called Sugar House Aerospace. They do what they call sugar cubes, and you can they start out being maybe a few centimeters wide up to about, maybe half a meter size box. You put your experiment in that, it'll go up. But the biggest, and then there were also representatives from spaceports. There's spaceports popping up all over the place. Colorado has one. Their motto is the first mile is free because we're a mile high state. Then there's also Mojave in California, and we have Spaceport America in New Mexico, and Michigan wants to build one, and Maine wants to build one. And many states are getting involved with this because it's a growing thing. But the big takeaway from this was that suborbital space now opens up suborbital and microgravity environments to not just researchers, but also educators. And so they talked about that being sort of a transformative kind of approach. And researchers and educators can, depending on their experiment, fly along with their research. Mm-hmm. Now, here on Earth, when we do chemistry experiments or physics or whatever, we're there and we've got our hands on it. Space people have always had to do it remotely. Astronomers have always had this problem. And space people, they've got to send stuff up to orbital space, and it's a robotic thing, and then it comes back down and they analyze their data. If you design your experiment the right way and you can get the money to go and fly, you can go up with your experiment and do it. So there are people at a number of universities and institutions that are doing that. So this is actually a very transformative technology that is really starting to take off. And in fact, one of the surprising outcomes is that it really it does take the science research in space and just puts it into people's hands in a way that it hadn't done that before.
I mean, it is, considering the amount of energy that's required to fly on a suborbital flight, there are a lot of really compelling launch providers out there and fairly small rocket platforms. NASA does a lot out of Wallops, and they also do some out of Alaska. There's some other flights that happen around the world. And I think, if you're looking to just figure out if your idea is even in the right direction, if you can think of a way to fly suborbital, you're only going to be up for a few hundred seconds or, a couple of, minutes at the most, and then you come back down. But maybe you can, in zero gravity, solve a couple of quick problems or make some quick sampling and get yourself moving in the right direction. It's a way to provide a certain level of certainty for a mission that, and then you spend the $10 million on your CubeSat launch or your $100 million on your, on your Earth observing.
And that's what they were talking about. I mean, there are some experiments in planetary science that went up that just basically wanted to see how, when you have a solar system forming and you have all these little rocks and pebbles and things bouncing together, how does that really work in the birth cloud? And so they went up. Josh Caldwell did this out of Florida, and they came up with a little program where they drop some projectiles into this dust, and they watch it in a microgravity environment, and it's a marble, essentially impacts into the dust, into the regolith, and as it bounces back up, it pulls some with it. So there's an electrostatic charge that pulls it together. So it's a very tiny little part of that long process of building planets, but you really do have to document it each step of the way. And this was a relatively inexpensive way to do it.
Yeah. Were there any other missions that you just thought, man, that's a really cool idea?
The fireflies in space was pretty cool. I didn't really think, and that was kind of interesting because the kids this is in Indiana, and the teacher was talking about how this worked and said that they were trying to come up with a state bug or something like that. And they said, well, the firefly. And some second graders said, well, do you suppose they light up in space? It's a chemical interaction. It probably does, but they didn't know. So they were talking with some fellows at Purdue, and the engineering department got involved and said, well, let's design an experiment and do it. And so they flew it on Blue Origin. And I think it was a couple of flights about 2 years ago or a year and a half ago. And they flew it, and they found out that they actually do light up in space.
Yeah, they're trying to join the 100-mile high club.
Exactly.
Yeah, well, we didn't go there. I don't, that's really good. Nobody said that in the audience. But, there's a number of experiments going on. There's a lot of stuff. There was one really interesting one where they haven't really implemented this yet, but they want to study the panic reaction that people might have in space. And what happens to you physiologically if you get up in space. So I'm just thinking myself, if I had that flight going up to apogee and then coming down, would I just say, holy crap, when I get to the top, or would I be scared to death, or what? And they're trying to, anticipate who would. You
have a hint of it when you're on like a roller coaster and you go over the roller coaster, or when you jump off something really high into water and you feel that feel of falling, except it never goes away. right?
Yeah. Well, Beth really told a compelling story about that. She's up there hanging in space. She was the first person to be hanging in the middle of a spacecraft, not attached to anything at apogee, because her pilot and co-pilot, they're strapped in. She gets up and she moves around. There was also a lot of discussion about when you get up there, you have to rehearse everything over and over and over again. You have to have a checklist, and it's on your wrist. And she had to have a checklist of get up, move yourself up off the seat, figure out where the arm is for your seat before you start floating around the cabin so that you can grab for it when you come back down. I mean, it was just an amazing, just like a checklist for any astronaut, really.
Yeah. Incredible. Alan.
Oh, and I have one other thing.
Oh, we're going to get to that right at the end.
Okay, I'll do it later.
Yeah.
Because I got to turn off my backdrop. Okay.
Alan.
Yes, hi. So this is a bit of a topic change here, getting into some basic physics. A team of Dutch astronomers who think that they found evidence of the arrow of time being baked into the basic physics of the universe, which is interesting. I mean, if you know anything about the arrow of time at all, it's the idea that although your fundamental physics formulae, they are time symmetrical, which means you can move them forward and backwards through time and it doesn't matter. And that's why things like stellarium work, to be able to show you, what the solar system looked like, say, 100 years ago. Although in real life, we find that it's a little more complicated than that. So something complicated like chemistry, you can't unfry an egg, you break something, you can't just stick it back together, you can't reverse that. But it usually holds that it's symmetrical in fairly simple things, and orbital calculations, relatively speaking, are simple interactions. And what this team have done is they've managed to break symmetry using the three-body problem.
So can you explain, just before you go into that, what is the three-body problem?
Okay, so if you take just with basic Newtonian physics, you simulate two objects and their interactions and how they orbit each other. That can be solved mathematically. Again, I keep saying simple. Newton had to invent calculus to work this out, but it can be done. Any undergraduate students can walk through the math. It's fairly simple. But when you add a third body, it becomes mathematically unsolvable.
Right.
I know mathematics centuries built their careers trying to figure it out, and eventually it can't be done.
Yeah, I think a great example of that, right, is you have like a planet and you have a moon going around the planet, and you can't tell which way. You can run that either way. You can have the moon go one way around the planet. You can run the video backwards in time, and the moon is going around the planet, and it's perfectly fine. But you can't do that with the three-body problem. You can't run it backwards for long enough, right?
Yeah, I mean, the way we solve three-body problems, just for when we have to do real-life calculations of, for example, setting a spaceship up or something where there's many more than three bodies, you just do a numerical calculation where you basically give it to a very fast computer and say, okay, let's work out each interaction individually, add them all up, do some vector addition, advance time by 1 second or 1 millisecond or whatever your resolution is, and just run this over and over and over again. And that's where you start running into chaos theory, right. Which is this kind of simulation. You can only calculate so far. You can only go so many decimal points. And because that is inevitably rounding off, it means that each sum is going to be slightly off from reality. And over time, these errors add up, and they do so exponentially. So you'll find slight deviation, right. Huge deviation, and then it becomes meaningless.
Yeah.
So what this team were doing, led by a Dutch astronomer, Mr. Buchholz, I believe is how it's pronounced. They basically took a very powerful computer and a very accurate simulation and managed to run it to over 100 decimal places. And a simple, there's that word again, three-body problem using three black holes. And they got them accurate enough that they were able to simulate, I think, up to 75 million years of interactions between these objects, and almost always then be able to reverse it and have it work.
Right.
But 5% of these problems still did not reverse. And at this level, they were working at a level where the deviations were smaller than the Planck distance.
Right. That's crazy.
Right. Which is just computers. What can they do now?
Yeah, I know. So just let's hang on that idea for just a second here, right? That they were simulating the interaction between these three black holes, and they were calculating the distance that these three black holes were from each other down to a level of precision that is greater than the Planck length, which is what? I don't even know the number, right? 1 × 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ possible length. So
Yeah. I mean, my understanding of that is that that's the smallest distance that really has any physical meaning in our universe. You go smaller than that and it doesn't matter, because that's where quantum effects become so big that it means nothing.
Right.
You can't work with this.
Yeah. And still, when they ran this simulation at that level of resolution, the errors crept in.
Yes.
Yeah.
And what they're arguing, therefore, is that this is no longer computer error. This is the universe's own resolution.
Wow.
So their point is that the universe itself will accumulate these errors if you try and, okay, now all the physicists, I'm sure, are tearing their hair out at this horrible mangling pad. But this is no longer a limitation of the computer, but the Planck length itself is affecting this.
Right.
And so their argument is that the very basic physics of the universe itself are not allowing these calculations to be reversed.
And so essentially this idea of the arrow of time, that you can run time in one direction and you get one outcome, and then you turn time around and run it the other way, and you should be able to get yourself back to the source, is more complicated than we thought. And we already thought it was super complicated.
We normally explain this by looking at thermodynamics and talking about entropy, but this is a simple system. There shouldn't be, maybe I'm extending myself a bit far here to say that shouldn't be a factor on such a simple thing. It's not like chemistry,
Yeah.
But there we have it. So draw your conclusions from that. So I guess time travel is impossible. We already knew that, but no.
Right. If you try
now
to travel,
we more know it.
If you try to travel back in time, you'll end up inside a black hole.
Right. Yeah, exactly.
Yeah.
Stuck between three black holes. Yeah.
Yeah, exactly. Yeah, totally. All right. Well, Alan, we're reaching the end of our hour. Alan, you are on my screen right now. So tell us something that you've worked on recently and where people can find out more about what you're doing.
Well, until recently, I was working an internship for Space in Africa, which is a Nigeria-based space news and the space industry news source. That seems to have come to an end. However, the season 3 of the Urban Astronomer podcast is coming up soon. I've almost finished recording content and interviewing people involved in South African astronomy. We'll be launching in a few weeks, and then a bit of a lag. It'll also be on the 365 Days of Astronomy podcast as well.
Fantastic. Alex, what are you working on?
I'm trying to bring my dissertation in for a landing. I've got one last paper to get out the door. I'm working on the application of convolutional neural networks to the problem of finding moon signals in the Kepler data, actually. So that's, I'll be here until about July, and then I'll start my postdoc.
Do you have a spoiler?
For where I'm heading?
Can you find evidence of moons in the Kepler data?
Yeah, I think so. I mean, we, the way we have to do it is train it on simulated data. We don't have an abundance of real moons in the data.
Yeah.
So when you do machine learning, you have to have a training set and then, apply it to the real data. When we train it and, test how well our classifier does, it does remarkably well. And I don't think it's too much of a spoiler to say that we've got some candidates that we think are quite interesting, but we're still looking at them and trying to make heads or tails of them. So we'll see.
Fantastic.
What happens.
Let us know when you actually do publish, when you're on the pre-press. That's good enough for me. We'll write a story on it.
Yeah, for sure.
Yeah, that's legit. And where can people find out more if they want to?
I've got my website, alexteachy.com, and I'd invite everybody to follow me on Twitter at alexteachy.
Fantastic. Carolyn, I left a few extra minutes just for you.
Oh, thank you. Well, my latest book just came out this month in the United States. It's called, can you see that?
Yeah.
There we go. It's called The Discovery of the Universe, A History of Astronomy and Observatories. And it was a requested book from my publisher because they wanted something to explain to the rest of the world who aren't astronomers about what observatories do and what they are. And when I got to writing it, I realized it really was kind of a history of the discovery of the universe. And so that's what we ended up calling it.
Yeah.
It's written for a very general audience, and there's no math. So I urge everybody to check it out. It's available on Amazon and better bookstores, and I think it's also available as an electronic book now too.
Yeah, there's almost like no other field. Our understanding of the field just goes in lockstep with the capability of the tools that astronomers, that the scientists have at their disposal. I mean, maybe particle physicists, right, as they get higher and higher energies, but as astronomers get a better telescope, they know more about the universe, and it just, rinse, repeat. And
well, this goes all the way from Stonehenge, actually even pre-Stonehenge, to something like the Ice Cube Neutrino Observatory.
Yeah.
So in a sense, particle studies are also part of astronomy. You can kind of make an argument about that, but we have to build these observatories to be able to see them. Can't detect them otherwise.
Well, congratulations. If people want to pick up a copy of your book, where do they find it?
Amazon.com. Also on my company's website, LochNessProductions.com, has a link to all the places you can buy it. You want to read any of my articles, I'm at thespacewriter.com, and I'm on Twitter at @spacewriter.
Perfect. All right. So if people are interested, of course, I've got we've been a little slow for the last couple of weeks. I'm sure you all understand, but actually we are, I'm trying to hire as many, I'm trying to give as much work to as many writers as we can with our, some of the freelance work that we have. So you're going to see a lot more articles coming out of Universe Today in the next couple of weeks. Because everyone's got to pay their bills. So
I'm available.
Yeah, okay, we'll talk. But also we've got Matt O'Dowd from PBS Spacetime is going to be joining me on my YouTube channel on Monday, and so if you want to come and hang out with me and Matt, that'll be on Monday at 5 p.m. Pacific time on my YouTube channel. So, all right, let's put everybody back on screen. There we all are. All right, well, thanks everyone for joining us today for another episode of the Weekly Space Hangout. Thanks to Amy for making another guest spot and telling us about her new book, again, Fighting for Space, Two Pilots and Their Historic Battle for Female Spaceflight. Available wherever books are sold, and also in your ear holes if you want. And thanks to Nancy and the rest of the Weekly Space Hangout crew. We couldn't do this without you. Thanks for everyone in the chats. And we will see all of you next week. Stay safe, everybody.
Stay
wash
safe.
your hands.
Yeah.
Bye-bye.
Yeah.
Stay at home, wash your hands. All right. Nice. All right, we'll see you all later.